Hello students, this is the Digital Knowledge Irshad Academy with a new video of OR logic function. Looking at the board, we have a logic gate is an electronic circuit that performs Boolean function. It can have one or more binary inputs that produces single binary output. This is the definition of a logic gate. Before going to circuit explanation, see that you have subscribed my channel and press bell icon so that the next video reaches you. Coming to the circuit explanation, we have two switches A and B. They are in parallel but connected in series with the battery and the lamp. For the first combination, we say that switch A and B both are open. That means they are 0 0. When both are open, there is no current flowing through the lamp. The circuit is broken. Therefore, the lamp does not light. For first combination, when A is 0, B is 0, the output is 0. For the second combination, when B is closed, A is open, this time the current can flow from here through switch B through lamp, and the lamp is going to light. And for the second combination, when switch B is closed, the lamp closed, the output is logic 1. For the second combination, when switch A is open, B is closed, the lamp is glowing. For the third combination, when switch B is open and switch A is closed, the current can flow from here through switch A through lamp back to the battery. The lamp will light and provide us the output 1. When fourth combination, when both A and B switches are closed, now there is a current flowing from negative to positive terminal through switch B through switch A to lamp, and the lamp is going to glow. For fourth combination, when both the inputs are 1 1, the output is 1. The Boolean expression for the OR gate is when two inputs A and B, the output Y is equal to A plus B. And in case of Boolean algebra, we will not call it A plus B, we will call it A or B. The same function can be performed by using two diodes in parallel. These are the two diodes connected in parallel. Positive voltage is connected to D2 unknown. Positive voltage is connected to D1 unknown. But the first combination, when there is a logic 0 voltage is applied here on cathode of D1, cathode of D2, they are not forward biased, and there is no current flowing from ground through RL. This circuit is open. This circuit is open, therefore there is no voltage output here across RL. Therefore we say when we are applying logic 0 voltage at the cathode, they both diodes are reverse biased and we do not get any output across RL. For the second combination, when B is forward biased, we are applying logic 1 voltage at the cathode. This is forward biased. Now the current starts to flow from ground through RL through conducting diode to positive terminal to ground. From this ground, the circuit is complete and we get here output voltage. For the second combination, when B is forward biased, we get one output voltage, logic 1 voltage in the output. For the third combination, when this is reversed biased but logic 1 voltage is applied at the cathode of D1, this D1 is forward biased and the current starts to flow from ground through RL through conducting diode to battery to ground. From this ground and current flowing from here develops a voltage. We take the output from here with respect to ground. For the third case, when A is logic 1, diode A is forward biased, B is reversed biased, there is output voltage across R2. For the fourth combination, when both the diodes are forward biased, we are applying logic 1 voltage here, we are applying logic 1 voltage here. Both are conducting and the current is flowing from ground through RL through cathode D2 to positive end of the battery to ground, and this, and also the current is flowing through D1, giving us the output voltage across RL. So when both are logic 1, we are getting 1 in the output. The same circuit logical operation can be performed by using two transistors. These two transistors are connected in parallel. VCC is connected to collector, VCC is connected to collector. For the first case, when both A and B are 0, 0, A is 0, B is 0, we are applying logic 0 voltages. They are reverse bias, they are not conducting. When they are not conducting, there is no current flowing from ground through RL through transistor T2, and also from ground through RL T1 to VCC. For the first case, there is no output voltage here. Why? Because both the transistors, they are cut off. For the second combination, when B is forward biased, we are applying a logic 1 voltage here. T2 is forward biased. When T2 is forward biased, the current can flow from ground through RL, through T2, through VCC positive, through negative, and back to ground, providing us the output voltage across RL for the second combination. For the third combination, when T2 is reverse biased and T1 is forward biased, by applying a logic 1 voltage here, we are applying logic 1 voltage here, and T1 is forward biased, current can flow from ground through RL through T1 transistor to positive VCC to negative VCC to ground, and from here we get output voltage across RL. For the fourth combination, when both logic 1 voltages are applied at A and B, T1 is forward biased, T2 is forward biased. Now the current can flow from ground through RL to conducting transistor T2 to positive VCC to ground, and then back to ground. Similarly here, the current can flow from ground through RL through conducting T1 to positive VCC to ground, and we get output voltage across RL. And the R function is Y is equal to A plus B. We are not going to call this a plus B, we will call this A or B. Now we can perform Boolean addition or Boolean logic operation of OR gate by using two switches in parallel. Two diodes in parallel can perform the same function. Two transistors in parallel can perform logical addition, and we have seen that this is the logic symbol for two input OR gate symbol. This is OR gate symbol. A, B are the two inputs. Output is Y is equal to A or B. Two input OR gate, four possible combination at the input, single output for each combination. Positive sign indicates a OR operation. This positive sign will indicate OR operation. Boolean expression for OR gate is Y is equal to A or B. When we are applying three inputs, there will be 8 possible input combinations. The Boolean expression will be Y is equal to A or B or C. Boolean expression of OR gate is Y is equal to A or B or C. For 4 input OR gate, A, B, C, D, we are applying 4 inputs. The output Boolean expression will be A or B or C or D. 4 input OR gate. 16 possible input combinations. Note that we will call this inclusive OR function. Why? Because it is including all input combinations. And the OR gate so far we have discussed is inclusive OR gate. Why? Because it includes all possible combinations, and when we exclude input combination, it becomes an exclusive OR gate. Now, a few important points. OR gate is considered as a coincidence detector for low inputs. When low level inputs coincide, it results in low outputs. Why? Because when the input A is 0, B is 0, the output is 0. OR logic gate is also called any gate. When any of the input is 1, output is 1. When the inputs are low, the output is low. We call this a coincidence detector for low inputs, and also called AND gate. Why? Because when any of the input is 1, output is 1. Here is input is 1, output is 1. When both the inputs are 1, the output is 1, and therefore we have performed logical addition or OR gate function by using two switches in parallel. Battery and a lamp, same can be performed by using two diodes in parallel, and the same OR gate logic function can be performed by using two transistors. That's all. In the next video we will study NOT gate. Thank you very much.